Hello everyone. Let's use a couple quick examples of waves from Physics 20. Basically we're going to be using the two formulas, velocity equals frequency times wavelength, and the other formula, t, the period of time, equals 1 over f. We're going to look at a few more formulas when we study waves and light a little later on in the course, but these two we're just going to do a quick review of before we move into Unit 1. Light from a blue laser diode has a period of 2.23 times 10 to the negative 15 seconds. Determine the laser light. First thing I want you to really be very careful. You have a constant on your data sheet. I'm just going to point it out to you. Top left, about a third from the bottom. You know that as soon as you read light, and they talk about speed of light, the speed of light will be 3.00 times 10 to the 8 meters per second. They do not have to give that to you in your question. So as soon as they talk about light, the speed of light, we will use 3.00 times 10 to the 8 meters per second unless told otherwise. You're passing through some other type of medium. But since we're passing through air, speed of light through air, 3 times 10 to the 8. So what we want to do is determine the frequency. Well, the first thing we know is we know its velocity. Just finished talking about it, 3.00 10 to the 8 meters per second. I also know the period, which we use as capital T, and that's 2.23 times 10 to the negative 15 seconds. If we want frequency, what we're going to use is this formula. T equals 1 over F. And we just have to manipulate that for frequency, and this is a quick one to manipulate. F equals 1 over T. Put your numbers in. 1 divided by 2.23 times 10 to the negative 15 should give us a fairly high frequency, and I'm just going to punch this quickly on my calculator to make sure the answer is right. 1 divided by 2.23 to the exponent negative 15 should give us 4.48 times 10 to the 14 hertz. And when we study electromagnetic radiation a little later on in this course, you'll learn the frequencies of different colors of light, frequencies of other forms of electromagnetic radiation. You'll learn frequencies and wavelengths, and you'll be able to classify different colors. Blue has this frequency. That's what makes that color blue, just for information's sakes. When you want wavelength, then we're going to use the other formula we talked about. Velocity equals frequency times wavelength. So wavelength will be equal to velocity divided by frequency. If we put our numbers in, 3.00 times 10 to the 8 meters per second divided by the frequency we just worked out, 4.48 times 10 to the 14 hertz, we should get, and again I'm just going to confirm this by punching it in, 3.00 to the exponent 8 divided by that exact answer, 6.69 times 10 to the, I'm just going to write this out here, 6.69 times 10 to the negative 7 meters. And if you look on your data sheet, I use the prefix nano, which is 10 to the negative 9. So this could work out as using a different prefix, so you don't have to use scientific notation, 669 nanometers. Be careful, there are many prefixes on our data sheet, tells you what its exponential value is, for each one. So two quick calculations using the period formula, using the velocity formula.